I worked for a large healthcare company in North Texas, and one of the fundamental problems when I first started being responsible for our data center facilities, the common question I would get asked is, tell us where these expensive assets are at. And I've been at this company now for 17 years, and at the very beginning, for me, it was very difficult to track things down. Where is this server? Where's the ones that were easy to find were things like generators and PDUs, right? Those are big floor-mounted assets that are easy to find. The harder ones to find is a small server that maybe one team moves around, or a network device that another team is moving around. Within that space, as myself and some other guys started getting more involved, we moved to we started implementing our own naming convention. We started applying our own tags and working in conjunction with finance. So we found a very basic IR barcode scanner. So now we could develop where things were at, naming convention, some way to track it, and then feed that information back over to finance instead of them giving us a sticker, which we were doing previously. That worked okay, but we still had a problem with movement because there's lots of people that work in data centers. Things change, parts get replaced. How do you keep track of it? And it was still a manual effort if we had to go through and scan devices within cabinets, hope we could find them, and see if things were up to date. And very quickly we found the information that we had in our database was only as accurate as the day we put that sticker on a device. If anybody's using those types of systems, I'm sure you recognize that challenge. The nice thing about RF code, and what I really like, is yes, they are active tags. They are more expensive than a passive tag, but you get a lot more value out of it. But it also allows me to then justify a 100% accuracy on, let's say, loose hard drives. In our world, we have to constantly be worried about the loss of patient data. The guys on the ground at a data center don't know what kind of data is on a given hard drive. So we assume it's all protected information. We err on the side of caution. So we tag every single hard drive and track it all the way to destruction. And it's that and that coverage from a HIPAA or a high-tech type of audit is invaluable in my book. In the very first year when we had an audit come through from our financial team to say, they came in and said, Mario, where is this asset? It was very simple. I could walk them right to the cabinet and show them. Oftentimes I would try to send them a report ahead of time and go, it's here in this cabinet, and here's a real-time stamp of when that item checked in. They still, if you're familiar with finance folks, they still want to put their hands on it. But it made it very simple. I could walk them right to the cabinet, show them the tag, show them the name of everything, serial numbers, and it matched up perfectly every single time. So it was very simple, very easy, and they really appreciated now the higher degree of accuracy we were able to present with all of those things. Having a integrated active asset system has allowed me to plan for multiple scenarios, fitting everything from our compliance aspect of managing physical assets, from managing the temperature and humidity, those kinds of things within the data center, adding those capabilities into networking closets, which oftentimes are not as rigidly managed as a data center because whether they're in a hospital or in a professional building, a business office building, now having a positive control and information about assets across our enterprise lets us know where things are deployed and where things are implemented and where things are at in storage. That's a huge benefit for the different teams where they can quickly go and find the asset they need when they need to replace a device. Right around the 2018 mark, we had an opportunity to move to new data centers. And so we took that opportunity and illustrated the challenge that was happening and needing to track and account for when we were going to take something out of an old data center and move it to a new one. And that's when we reached out and we found that an active asset management system was going to really fit the bill. So we spent time, we tagged everything within our legacy data centers so we knew exactly where they were at. By deploying those kinds of things, when we went through the exercise of migrating and those lift and shift movements of moving from one data center physical location to another, we could see things actually leave a location and show up at the new location. I could measure time between shipments, and we could identify exactly which cabinet something went into when it landed at the new location, which was enormously helpful. What we try to do, oftentimes we try to leverage, as we scaled out, we try to leverage a technology as much as we can, try to stretch it as far as we can. We've actually moved our asset management system beyond just the data centers, and we now have deployed those same active sensors in network closets around. We have close to 500 MDFs across 25 facilities, probably 400 clinics in and around North Texas. So lots and lots of assets, close to 5,000 networking assets alone. And then that allows us now to have in a single repository the physical location of things stored across, 4 counties. Makes it really nice to feed all of that then, whether it's in a storage facility, and it's not just now the data center team using this, it's our network operations team, it's our server engineering team, and even some other teams. We now bring all of that physical asset information. We can feed it to our finance team. We can now also feed it up into our ITSM system. And by marrying all of those things together, we now have a common layer of data to start from for that asset, that physical asset lifecycle, which makes it really nice as we start planning for the future. We know exactly what we have, we know exactly where it's at, and we know exactly what to plan for when it's time to start cycling those assets out. That's an enormous benefit because there's lots and lots of use cases that are very valuable, and when they come from the same set of data, then that information is accurate across all of those, as opposed to lots of different data sources, which then could lead to drift in that asset inventory information. We know now, because we track it at the very beginning, then we know when it moves onto the data center floor. We now have a better understanding of its life cycle, when it goes, gets plugged in, when it shows up in a cabinet. Now that we're also we're adding more integration with RF code, we're now able to detect when it gets on the network. Was this device, as long as we start batching up, is it in this PDU? Is it in this? We're starting to track things like outlets, where things are plugged in, and marrying those different pieces of information together so that we can start saying how many, not just how much U space is consumed, but how many outlets within a cabinet are available. Whether we have enough in the A side or the B side. Do we have enough power within that cabinet for a new system? We may have enough use space, but do we have enough power? So that's where those APIs have really become beneficial, starting to marry that data together to get a much deeper understanding of where do we need to plan for space, where do we need to shift equipment around, or in some cases even request new cabinet space and new power from our provider. So understanding when we have systems connected to A side and B side power, A side and B side network, understanding those because we have that physical relationships documented in that physical asset system allows us to feed that into a CMDB, our configuration management database, which then influences how impactful change is or how impactful an incident is. That same then capacity planning and understanding what type of physical hardware we have, how much capacity we have in those systems, then leads us into, can we repurpose equipment? Are we using the right equipment in the right space? A perfect example is we were able to plan out a replacement of legacy blade chassis with rack mount servers. And by doing that and planning ahead, we were actually able to reduce our power requirements and reduce space, free up space within the data center. But because we were able to look at the information in our asset system and understand the scope of what an existing piece of equipment, be it maybe 4 cabinets of blade chassis, 4 chassis high, each cabinet having 60 amp power in those. Planning ahead, we now realized, okay, we can actually shift that workload down into 2 new cabinets with 30 amp circuits because of the change in technology and planning ahead and having the right information. That space and capability planning, understanding where temperature impacts, temperature spikes, whether it's incoming or outgoing, whether it's at the top or the bottom, allows us to really plan much farther ahead and prepare. By having that space planning capability, it allows me to then to move into detailed reporting to illustrate to my leadership why we have maybe an empty cabinet, because that's really not truly an empty cabinet. It's dedicated space for failover or for replacement gear. If you buy a new storage array, you can't rip the old one out and put the new one in. You have to give it time. You have to be able to put both of them online at the same time in order to replicate all of that data. So if all of a sudden you give up all of your space and you don't have space for that new storage array, which it's depending on how you're handling things, you're replacing something every 4 to 5 years, people will ask, why do you have empty cabinets? Why can't we fill those up? I have those already earmarked within the system. This is dedicated swap space, dedicated failover space for things like large networking, core equipment, all the different kind of core technologies has dedicated space so we can have an upgrade path for that equipment. And I've already dedicated that cabinet space. That detailed reporting allows me to then go back to my leadership and say, we need more power. I need to add more cabinets. I need to add more power, especially when we can get ahead of the larger project planning and see what's happening on the horizon. We've actually added a receiver into our storage and receiving rooms, so when new items come in, they're tagged immediately as a first step before anything gets powered up, before we're immediately tagging it and documenting things like PO numbers and requisition numbers. So now those financial types of numbers or supply chain numbers track along with the tag number throughout the life cycle of that piece of equipment. So we know who bought it, when it was received, where it went to. And so when we start adding then more information about maybe what is the new name, we can always go back and find that device even if somebody doesn't remember the name. they can always look up, well, what was the original PO? What was the original rec number? That, by starting at the very beginning, before it's powered on, allows us to have very, very accurate asset tracking. Having a integrated active asset system has allowed me to plan for multiple scenarios, fitting everything from our compliance aspect of managing physical assets, from managing the temperature and humidity, those kinds of things within the data center, adding those capabilities into networking closets, which oftentimes are not as rigidly managed as a data center, because whether they're in a hospital or in a professional building, a business office building, now having a positive control and information about assets across our enterprise lets us know where things are deployed and where things are implemented and where things are at in storage. That's a huge benefit for the different teams, where they can quickly go and find the asset they need when they need to replace a device. It gives us positive information for the security team as we engage with them on vulnerability management. They know where devices are at. They understand the relationships of those devices, what things are plugged into where. It allows them to know what the surface area of risk is of a given vulnerability. Then we move into that physical access. Within the data centers, we're actually scaling out our video surveillance and door sensor capability with RF code out to our closets. So now we have physical observation in network closets. That allows us to now say, if somebody gets into a closet that maybe shouldn't be, we have an opportunity to be flagged about that. We get an alert about that. We know when somebody's going into a closet. And now that same level of observability within the data center, we move out to our network closets. That gets us all the way down to having a clear, positive control across our core enterprise services, especially networking, all the way out to the customer.